Welcome to SSR Pharma Media, your trusted source for pharma knowledge. Pharmaceutical Inorganic Chemistry and Pharmaceutical Analysis MCQ series, your exam power boost. Today we are going to discuss about redox titration. So it is a topic present under the Pharmaceutical Inorganic Chemistry and Pharmaceutical Analysis subjects. Prepare, practice, succeed. So in redox titration, we are going to discuss about introduction about redox titration, concepts of oxidation and reduction, and types of redox titrations. So in these types are permanganometry, seriometry, iodimetry, iodometry titrations, and titrations with potassium iodate. So these are all the types of redox titration. So now we are going to discuss about these topics. An introduction. Redox titrations are volumetric analytical method based on oxidation. So based on oxidation and reduction reaction between analyte and titrant. So they are widely used for estimating reducing agents or oxidizing agent in pharmaceutical, environmental and industrial samples. So the features of the redox titrations are, it involves an exchange in oxidation number. Reaction reaches a sharp endpoint if suitable indicators or self-indicating titrants are used. So concept of oxidation and reduction. So oxidation, what is oxidation? So oxidation means it's a loss of electron. So due to oxidation reaction, increase in oxidation number, that means, and gain of oxygen and loss of hydrogen. So example, so this is the ferrous ion, when it's get reduced to increase, convert into ferric ion, so that the increasing the oxidation number and its loss of electron takes place. And in redox reactions means is a gain of electrons. So due to the redox reaction, decrease in oxidation number and loss of oxygen and gain of hydrogen takes place. So for example, in manganate ion, so undergoes the reduction reactions. So manganate ions undergoes the reduction reaction. It's gain the 5 number of electron and it's get reduced into manganese ion, Mn2 plus ions. And ferric ions, here ferrous ions get oxidized and converted into ferric ion. Next, example for oxidizing agent. So accept the electrons is reduced. Example, potassium permanganate, potassium chromate, and ferrous ion and iodide. And reducing agents, so donate electrons. So is oxidized. That means, so oxidizing agent means it reduce the electron. So during reduce due to the electron acceptance, and these substance undergoes the reduction reaction. So reducing agents like as ferrous sulfate and stannous ions and ferric oxide and thiosulfate, sodium thiosulfate. So these ions are example for reducing agent. So these reducing agent during reactions, it get oxidized. So due to donation of the electrons. So these are all the introduction concept of oxidation and reduction. Redox titrations are based on, so option C, electron transfer reactions. So redox titration involves oxidation reduction reactions where electrons are transferred, which is on oxidation process. So option C, iodide, it's get oxidized and converted into iodine. That means iodide to iodine involves loss of electron. So it is the oxidation process. Reducing agents. So example, answer B, donates electron and it's oxidized. So already I told reducing agent means it undergoes the oxidation reactions. So due to the donation of electrons. And next is the types of redox titration, permanganometry. So titrant is KMnO4, potassium permanganate. This reaction takes place under acidic medium and the indicators use self-indicator, and in the end point is purple color to pink color produced. And seriometric, steric ions are a titrant as it is takes place under the acidic medium, and indicator ferroin or ferrous sulfate is used as a ferrous ions are used as a indicator. So color changes at the end point yellow to colorless. And iodimetry means so iodine solution used as a titrant, and if this reaction takes place under the neutral or slightly acidic conditions, starch is used as an indicator. It is a type of direct titrations, direct titration of reductant, because iodine is oxidizing agent, so it undergoes the reduction reactions, so it is called reductant. Iodometry. So iodometry means it's a liberated iodines are titrated with sodium thiosulfate, and it takes place under the acidic conditions and using excess of potassium iodide solution, and starch used as an indicator, and sodium thiosulfate is a titrations. That means it is titrant sodium thiosulfate will use. And potassium iodide titrations are potassium iodide is used as a titrant. It takes place under the acidic and medium, and also potassium iodide also used as a reducing agent, and starch is used as a indicator. So primary standard, it is used as a primary standard for the titrations of for standardization of potassium permanganate and seriometry. Steric ions. So identify the correctly matched pair. So option B, serimetry. So 2 ferrous salt. Seriometry uses steric ammonium sulfate. So iodometry uses thiosulfate, not iodine. In iodometric titration, iodine is, so option C, liberated in situ form from iodide by oxidant. So that means, so iodide in iodometry, iodide is converted into iodine, which is then titrated with thiosulfate. KMnO4 is most effective as an oxidizing agent in, answer is option B, acidic medium. So in acidic medium, permanganate ion is oxidized into manganese ion. Endpoint in permanganate titration is, so option B, permanent light pink color. Steric ammonium sulfate is used in, option C, acidic solution. Indicators commonly used in serimetry is, option B, ferroin. Iodine solution is oxidized using, option C, potassium iodate. And in potassium iodate is used as a primary standard. It reacts iodine in acidic medium to release iodide. So this liberated iodide is used for the standardization of potassium thiosulfate, sodium thiosulfate or potassium permanganate. In iodometry, the titrant used for liberated iodine is, so option B, sodium thiosulfate. The substance assayed by iodometry is, so option C, copper salt. So copper ion react with the potassium iodide and release iodine. So this released iodine is assayed by determined by iodometric method. And potassium iodate reacts with potassium iodide in acid to form option B, iodide. That means potassium iodide react with the potassium iodate react with the potassium iodide in acidic medium to liberate the iodine. So they liberate the iodine. So next we'll discuss about the types of indicators used in redox titration. So here there are three types of indicators are used: internal indicator, external indicator, and self indicator. So internal indicator means the indicators are added directly into the titration mixture, so undergoes redox color changes. So example, diphenylamine titration and N-phenylanthranilic acid and ferroin starch. So these are also not it is the indicators of the external indicator examples. So diphenylamine, N-phenylanthranilic acid, ferroin and starch. So next is a external indicator. So in external indicator not added to the titration mixture. So reaction drops tested on indicator on tiles or paper after each addition of the titrant. An example, potassium ferricyanide is used as an external indicator. And self indicator, so it is auto reduction indicator. It is titrant or analyte itself shows color change at the endpoint. For example, potassium permanganate and potassium dichromate. So these are all the titrant is used in the redox titration. So this titrant itself acts as an indicator and it produces the color change. So it is type of example for the self indicator. The assay of hydrogen peroxide in pharmaceutical is commonly performed using which type of titration? Option C, permanganometry. So hydrogen peroxide is assayed by permanganometry in acidic medium where it is act as a reducing agent and permanganometry act as a oxidizing agent. So it is a type of permanganometric titration. So here potassium permanganate is acting as a oxidizing agent and hydrogen peroxide is used as a reducing agent. So for the redox titration we require reducing agent and oxidizing agent. So each other react in the acidic medium and we'll get the endpoint. So reducing agent undergoes oxidation reaction. Oxidizing agents undergoes reduction reaction and to form the products or salts. The assay of ascorbic acid tablet is based on option B, seric ammonium sulfate is used as a titrant. That means seriometry. Assay of ascorbic acid is assayed by seriometric method or serimetric method. Which drug is assayed by iodometric titration involving indirect liberation of iodine? So option B, chlorinated lime. It's a type of bleaching powder. So bleaching powder is assayed by iodometric method because bleaching powder react with the acetic acid and it is to produce the iodine. So that liberated iodines react with the sodium thiosulfate. So it is called iodometric method. And bleaching powder, it is containing chlorine ion and it's react with the potassium iodide and in the presence of acetic acid and it liberate the iodine. So this liberated iodine is titrated with sodium thiosulfate and in this titration starch is used as an indicator. The assay of ferrous sulfate is typically performed using which redox titration? So ferrous sulfate is in redox titration, tell in the comment box. So thank you. So join in our WhatsApp community. You will get hands-on material. So thank you. Like, subscribe and share.